Welcome back to the wonderful world of Java. Today, I'm going to explain linked lists to the best of my abilities. I've written a linked list ahead of time in Java. So here's what I did first. I have a public class, and I set a node, and this node has a pointer of next and tail, and it holds a value, an integer value. I've also written this in C++ actually. If I can find it, might look at it. The implementation is very similar, if not the same. But I've been practicing this to pretty much learn this. I know in Java, it has a linked list class that it's already implemented in it. Oh, my bad. Import Java. We'll do this. I think it's all encompassed in that. Oh. Funny thing is, if let's see. This will be interesting. Nah, because I named it linked list. So it'll probably be overridden or I'll probably overwrite it. But it essentially will work pretty similar because it'll overwrite it because I actually named my written class linked list. So anyway, here's the implementation of it though, or should I call it the driver. Here's the linked list object of the class that I've written of this class, which actually extends the node. That's how we have access to next and tail. On the driver, I made a method called add, which adds to the linked list. And here it is. Within add, it creates a new value of node. And that node would be this class, which means that it has a next pointer. Well, it's technically not a pointer. It's an object of node, but it has a next. So I'm using them like pointers. And then it has a tail, and each one of these nodes has a value in it. So I assign the value from this parameter, and I called it val. Within the driver, here's the value that I'm putting in there. So anyway, the first time we go through here, it says if the next value, if the next node equals null, and I'm using this as the root. The first one is the root. And if it equals null, which means there's no value in the linked list, then I make this next, which pretty much means the one that I'm inserting in there. And I'm making it equal this new node value, which is already assigned the value within the parameter. And then I make tail equal this node, the head, which in this case is next. And then it'll jump out of this class. And then within the driver, it'll do the same thing, but then we have 30. But now when it comes in here, it's gonna not be null because the first head, the root, was null. It'll jump all the way to this else because the first one's not null. Then it'll say this tail next, which means the next area that is pointing to in the list will now equal this new value. And now this tail will now shift to the next tail value. So basically explaining exactly what I did, I already set the next tail value to the new value. The next one, the current tail value is equal the head or the root. So the current one was 24. So here I say the next one, which essentially has no value, but I assigned it to the new value. And then we make the current tail, we make it equal the next value. So that tail is shifting value. It's shifting to the next one. So now it's no longer equal the root, but now equal the next. So now the next tail now equals 30. And it keeps doing that until I add all the data in here. Now this, print the first list. I implemented this line because I was testing the delete function and I wanted to see, pretty much I was error checking when I was writing this. So when I first go to a print list, which means I'm just going to print everything, I created within the parameter a node called temp. And I put the linked list of this object of the linked list into there. So you could see it as this. The parameter is pretty much kind of acting like a pointer within itself. In this case, because now I could read the value of the entire list, but the first one it points to will be the root node. So while the next node does not equal null, it'll keep looping here. So how that works is just like up here, I'm shifting it to the next value, and then I'm printing the current value. And I keep doing that until all the values is printed. So what will happen here is down here on the console, it should print 24, 30, 40, 50, 60 the first time. And now after the deletion, after the first print, I say delete the value of 30, and then I reprint the list. So how does that work? So in the delete parameter, the delete method, I say int value, parameter value, or val, and then I made a new pointer to the previous node. I had to do this because when you're shifting through the linked list, you're losing the pointer from the previous tail. So you need to have a way to keep track of the previous tail value. So now I have essentially 3 pointers, one for the root, one for the tail, and one for the previous value. So here I make the previous equal tail off the bat. Then I say if the next value, which now I'm searching for, if the root value, that's why I said this, looking for the one specific root value, if it equals what I'm trying to delete, then I shift this root value to make it equal the next root value. Now this is kind of confusing over here, next, because I don't have another name for it. I'm pretty much saying make this current root value equal the next value within this root value. So that's what next essentially means. So pretty much this is making the root equal the next value onto my list. So now it equals 30. 30 becomes the new root if I'm deleting 24. That's what that's saying. And then when it prints it, it'll print all the numbers except for 30. But in our current case that we have in the main method, the current case, we're deleting 30. So that doesn't happen. What happens is we skip through here. None of this is valid. It doesn't equal this value. So we go to this else. So this tail will equal next. So what am I doing here? I'm basically assigning tail to the root value. And then on this while statement, I'm looking for the value of the tail to replace. That's what I'm looking to replace. So right here it says, while this value does not equal the value, so until we have an equal in value, we'll say the previous value will equal this tail. And then we're shifting through the linked list by saying this tail will equal the next value within the list. And I'll keep doing this, but in our here in our first run, it'll only go through it like maybe twice. It'll go through here, be like, okay, then twice, then this will be the value we're looking. I'll run into it, and then it'll break out of here because it will equal that value. So here we'll say, okay, well, tail will now equal the previous value because this previous value is always behind this tail. And then from here, I say, well, now I'm going to make this tail. This next tail will equal the next value. So pretty much I'm unconnecting the link from the first link from that 30 and connecting it to this. So in theory, it should be 24, 40, 50, 60. Now I'm going to test this. See, after deletion, 20, 40, 50, 60. So it's just like I said. The first loop, it's 20, 30, 40, 50, 60. After deleting it, it is 20, 40, 50, 60. And I could delete more if I want. I could delete 50. And 50 should be missing from that. So let's see. And it is 20, 40, 60. The original one, we have 24, 30, 40, 50, 60. So 30's gone and 50's gone from here. So you see, in Java, it's much easier to do a linked list. than it is in C++, because C++ we're actually dealing with pointers, and with C we're dealing with pointers. But essentially we could do the same thing. And I thought that was cool, but you don't really have to go through all of this hassle. Matter of fact, let's go see, because I know Java has its own linked list built in. I'm going to make a new project and test that real quick. There we go. See, import Java linked list. Why I could show you this earlier was because I believe the Java linked list is the same name as the one that I named the class. And it is. So it would have been overwriting. And I believe the methods are different though. Oh, never mind. I guess I did the same thing. Well, some of it is different, I believe. Actually, I could just copy and paste my old work here. Essentially because it's the same. Except some things are different. And I know Java implements different method names for some of those. Oh, well, I could do this. And now all that's legit. So I know there's no print list method in the Java one. Yeah, I mean, then I could use a regular for loop of a get to actually print this. But there is a remove method, I think. Let's see. Yes, there is. And these are the only things that are different is the printing. Let's see if I can remember this for each, the thing that I was having trouble with before. So ironic, I did figure this out earlier and forgot it. It's archaic. It's not, but it feels like it is. I'm gonna play with this for a bit. I don't think that's correct. I know I figured this out earlier. Let me see if I have it here somewhere. I can playground. Yeah, like right here. I imagined it. And since I did nothing but that, Hmm. Interesting. I don't really want to add anything. I know I could use a regular for loop for that. Okay. We'll just use a regular for loop. I equals 0, I. Let's test the first one. And I get why that happened. That's why I don't like. Yeah. Oh, my bad. That's why I don't like running that. So I believe you are supposed to do that. So you got 20, 40, but I have 60. 90 size 5. 1, 2, 3, 4, 5, which is 0, 1, 2, 3, 4. Exception after main 40. Twenty, 30, 40, 50. Let's see, I equals 0, I less than 4. Well, I know it's flipping outside of there. I'm reducing it, trying not to crash it. Time for a debugger to see exactly how this is happening. Okay, that's annoying. Really annoying. Huh. I'm sure I loop once. Just testing it. It'd be nice if I could actually check that out. Very interesting. Let's just test it like this then. And then if I print it up to 4, yeah, 0, 1, 2, 3. So it should be looping for 3 to make that happen. And that's why I prefer to do it the other way, if at all possible. So if you can do it the other way, you can prevent that from happening. This way is very bug prone either way. So even if I can figure this one out, very bug prone. Actually, 5 ought to do it then. Sheesh. I don't know why that worked. I mean, that didn't work. That makes no sense to me. But if I remove it, then it'll be like, oh, I'll complain here. But if I remove this, then it will not complain. I wonder if it's actually trying to remove it, like kind of like removing a string, and maybe, but no, because it says index out of bound. Oh, I get it. I get what I'm doing wrong. So I'm trying to remove it like my method, like the one that I ran. This is working like this. So let's say I want to remove 50, 0, 1, 2, 3. So this would remove 50, and this would remove 60. Yep. And then if I was to reloop it, so 0, 1, 2, 3, 50's gone from this list. So if I was going to reloop it, for example, interesting. I was going to reloop it. Obviously, I'll go over the bounds. So I have to do this. See? So that's what I was doing wrong. Now, this is what I was kind of explaining in my previous videos why I did not want to use the for loop in such a way. I did not want to use the for loop in such a way because if you do, it makes it easy to do that index out of bound thing. So what I'm trying to do is loop my, I'm trying to do this for each loop like this, except instead of in the array, I want to actually do it within the linked list. Because I know that if I can do that, then I won't have to worry about that because I'll just loop all the objects. I'll just loop all the objects within there. So I'll just loop all the way it's supposed to be. So I'm going to take a look at this. So here on this one, I've written this a while back. I've written this a while back. So I've written this a while back, like I said. So anyways, I've written this thing a while back. So int I in the array, and then just print that. So let's see if I can figure out how to make this work. Instead of saying within the array, I want to say within the linked list though. But I don't think that works like that. I think I would literally have to say within one, which I've been trying to do. It seems not to work though. It says it can't convert object into integer. No, it is an object, that's for sure. don't need to rename it. Wow. It don't work. But let me go examine this program I've written before with this array. I did this from, sure if I did this in a video or not, I'm uncertain. Maybe I just did this for fun. This array was defined by me here, but it is of that. I'll have to do some research on that one to figure that out. Matter of fact, it would be worth doing it right here on this video. Let's do it. I do need to figure that out. If I can figure that out, it'll make life easier. I know I can do the iterator thing. Here's one, except this is with the string, so like this. Let's try to mimic it. This is a string with his linked list. I'm trying to do an integer. Well, I'm wondering why this don't work. Did I spell it wrong? No. Interesting. Iterator might be the only way to do it. The numbers. This is in a beginner's book. Okay, let's try the iterator then. It's better than doing what I was doing before when you think about it. So let's see if this works in my case. I'm curious. Iterator. I hate that auto spelling always. And then you gotta do the import, right? Import, oh, well, import Java iterator. And this would be better. So yes, you've used a while loop just like that. Has next. And then you go system. I think that'll do it. And of course, you have to give credit. If you do borrow code, you always must give credit. Now I am going to delete this one anyways. Okay, so let's see. It should work. Oh, I was wrong. Iterator. It has next, true. Then you gotta convert this. There you go. So 24, 30, 40, 50, 60. And if I was to use the same method, it'd be removing it and it will print it. So if I did this, for example, interesting. Oh yeah, I guess I'd have to do the iterator after the removing. Yep, essentially. Okay, yeah. So that'd be the best way to do it if you use the iterator. But I'm not using that because I didn't come up with that solution. But yeah, the best way to do it would be with an iterator because as you saw earlier in the video, when you're looping through this, you really got to understand how this is in here. So when you're looping through, you won't go over the index. And my mistake previously in the video was when I did the whole remove, I was thinking the way that I implemented mine. Because remember, the way I implemented mine, I actually put in the value and it searches to the value. But in the actual Java linked list, it's more like an array where you would delete it based upon its position within it. But obviously, it's a linked list and not an array. But it essentially works the same in how you would remove it. And that's where my mistakes lie. So yeah, I was thinking in the lines of how I implemented it versus how Java implements it. But that's the beauty of implementing your own data structure. You really do decide how it's implemented and how it works, and the inners and outs, the ins and outs of how you design the data structure versus if you were to use someone else's. I would argue to say that in truth, you would probably not want to implement your own if Java or whatever programming language you have has its own implementation. Stick with that. But I'm pretty sure for example, coding interviews, you'll most likely have to implement your own. And in that case, you have to implement your own. But other than that, in actual real code, no, I wouldn't even implement my own unless I'm just doing it just for the sake of practicing it. But keep in mind that people who've actually implemented these things, usually it's more than one programmer who's done it. A lot of research has been taken into it. That code's been optimized versus what I've done. Plus, in my code, it only works with int values, though I have made code to where it could work in multiple values, and you can. There's a lot more work to it. But as you can see, to make it work perfectly, you have to use like a try catch, and you have to catch all the mistakes before it actually goes in there so the data structure doesn't break itself, which you don't have to worry about if you're using a built-in library. So that's why I would always recommend using a built-in library. That's the Java data structure of linked lists. And the beauty of linked lists is it can keep growing. There's no limit to it. And similar to array lists, I would say, it just keeps growing, except with array list, which is totally different in a sense that it's actually an array, copying the old array to a new array, delete the old array, and it keeps expanding itself. So yeah, the array has more stuff going on in that way than a linked list. Linked list is really just a bunch of pointers pointing to the next value. And ironically, even in Java, it's that way. But there's no access to arrays in Java, so it's all here to objects. I'm going to quit Eclipse and look for my other code, show you what I mean. If I can find my C++ code. Let's see, practice linked list 2020. I did it all in one main. I normally don't do it all in one main. I normally do put it in many. But here's C++. Now it's essentially, oh, I did code it. No, it's essentially the same So you have int value, since I made it double. Here's a node to next, which is serving, even though I guess I made it more confusing because I did have a root here. Because I wanted to define root more instead of do exactly what I did, because I wanted to just use root once and then connect everything to root in a more tangible way than in the Java one. But see, this asterisk is a pointer. All these are pointers. Even next is a pointer. And here's the value. So here I decided I want to hold int values and double. So yeah, in a node, you can hold multiple values. You can hold objects. You could hold graphs if you wanted to. You can hold a lot of things in these data structures and access them. That's the amazing part about them. You could probably even use a hash map and put a whole bunch of linked lists in those hash maps. And then you can search in alphabetical order for specific key terms. You could do a lot combining the data structures. But anyway, this essentially works the same, and the same as my Java one. Insert integer, what I call in C++, we don't call them methods, you call them functions. Here's a new node pointer, but the difference within here, and I'm not sure if I did the right thing here, but in here, you're supposed to actually delete this because there's no garbage collector. So this is actually, if I did not delete this, this would actually be a memory leak if it's not deleted. So you literally have to delete it. Here I attempted to delete all of it here because I delete the node, which I don't think this needs to be deleted because there's no new there. But I deleted all this here within I call it garbage collector, ironically. And here I did this again. I made a pointer to the root. And this is the printing of the values of the pointer. And n, which is the value. And here we go again. Temp now shifts to the next one. So I'm shifting through within this print method. I set tail to null when I'm done with the garbage collector. Here's a delete node. Here I know I'm trying to delete all this stuff. And here's how I implemented it. Delete the node, print garbage collector. Actually, I think this is a memory leak because what I needed to do here to make it not a memory leak is in the garbage collector. Actually, no, maybe it's not. I'll have to debug it. But it could be. Because I deleted the root and I kept going here and I deleted this and then I set tail to null. So I'm deleting the values to this. Previous is not. Previous is just a pointer so I can delete things like I did earlier. Made it equal the previous, just like it did before. Which the only thing I would really change about this code is I would make a pointer to point to this node and just keep deleting it that way. That's how I fix this. But you get the general idea of how this works. And that's in C++. I deleted 50 at some point. Doesn't reprint it though. Interesting though. Not sure if that delete not actually worked. Garbage collector, print. Let me see something here. Yeah, I think this code's bugged a little. But I thought I got this working at some point. Let's look at the delete node. Yeah, this code I don't think was perfected. I solved it in Java because I'm a little lazy. Let's see. Let's launch it. Let's go to linked list. Oh boy. Here you equals tail next. Yeah, it's not deleting it. And what I'm going to do is copy my implementation here. And then just translate the code to C++, see about that. This would be the equivalent of that, except I did this all for a while loop, and then I said if the value equals, which would basically be like else within here, instead of doing else, did it like this, because this handles that. Okay. Previous next. There's previous equals root. Previous equals this tail. This will be interesting. Let's do some debugging. Just to make sure I did it all right. Essentially, it's the same thing. Well, you got to compile the code. Interesting. All right, I did a little playing with this thing, a little off screen, and it turns out my linked list works, except it does not delete the last integer. See, 10, 20, 30, 50. Pretty interesting that it does do that, but you get the main idea. I'll probably experiment with this later on to see about getting that last one deleted. But it's interesting how in Java, since Java is a less complicated programming language, it does do that on mine. Even if, because I copied the code I've written here, try to implement it here. I guess I could try to do this again and see if I did the whole thing on exact syntax. Well, it won't be the same syntax, but algorithm, to see if it will work that way. It's essentially this. It's this. There's something missing though. Something missing. But I can't put my foot on it. Well, this shifts through it. I guess I could play with this just a little bit more. Maybe this is it. But yeah, like on this one, as we saw before, I could delete the last one. But you get the main idea of how linked list works. So for now, I'm just going to end this video here. Thanks for watching. I'm going to go over the virtual classes next in Java and then move on further towards C, unless I do some more interesting stuff in Java outside of just going over these basics. And we'll probably review. Yeah, that's what we'll do because it makes more sense to me. See you later.